I want to go over the training mat this morning. This is a training mat. It's a sales tool that's provided in each of the mannequin kits. It's designed to quickly and in narrative form tell the story of how intubation has evolved, why we have the tracheal access problem we have with a video laryngoscope, and how the current tools don't quite solve the problem and our tool fully solves the problem. So the story is on the mat here, and I'll go through each piece of the story real quick here. Intubation is essentially solving a geometry problem. This is the geometry of the normal human airway. It's serpentine in nature. This icon is serpentine. And the key points of the geometry problem is there's two curves. Those curves are in opposite directions. It's the primary curve and the secondary curve, and the inflection point or the direction changes at the vocal cords. And the key understanding is this is serpentine geometry. We solve the geometry problem with intubation systems. So whenever you talk to somebody about intubation, you should speak in terms of a system. This system has three components. It's got an operator, it's got visualization equipment, which can be a video laryngoscope or a direct laryngoscope. We're most interested in the video laryngoscope. And then there's tracheal access equipment. That's what we sell, is dynamic tracheal access. Dynamic tracheal access means that the introducer has a dynamic tip. It can move in an anterior and posterior fashion. It's controlled by the handle. It has a flexible shaft, and that shaft is conforming, allows the introducer to conform to the anterior and posterior curves of the airway. So it can actually move through in a snake-like fashion, which is critical for a smooth intubation. And then we're going to move over here to the evolution of intubation geometry. And effectively, what we have is the different eras of intubation here, and then the different characteristics of each era here. So intubation started in 1940. This is the predominant geometric theory. So this is what anesthesiologists and ED docs have in their head. This was invented in 1944 by a guy named Bannister. And the important thing to understand is it's all linear. So it's all a bunch of straight lines. You can see there's three straight lines there. Visualization. A direct laryngoscope flattens the first curve, eliminates the inflection point by lifting the jaw and tongue, and that creates a straight line to the vocal cords. And that's how we see the vocal cords, is direct line of sight visualization when we're using a direct laryngoscope. So the geometry, we change that linear geometry, or excuse me, that serpentine geometry to linear geometry with the direct laryngoscope. Tracheal access equipment are mainly bougies and malleable stylets, and those are designed to use in a line of sight or a straight line linear geometry, and that's tracheal access. Okay, the reason we fail with the direct laryngoscope, and this is really important, is it's really hard to go from serpentine geometry to linear geometry. And so if we can't see the vocal cords, if we can't create that straight line, then we fail, and the failure is due to visualization. Okay, so failure drives innovation. In the early 2000s, the video laryngoscope era began with really the glide scope. And instead of aligning axes, now what we do is we look around the corner, so we don't change the geometry. And this is serpentine geometry. Okay, importantly, that means tracheal access is now serpentine, and that's where all the problems start. So visualization looks around the corner, but that means that we're using serpentine geometry. So this is the solution so far. a rigid pre-curved stylet. You can take a malleable stylet and pre-curve it. Importantly, you can only curve it in an anterior direction, so it can only solve the primary curve when we're accessing the trachea. It cannot solve the inflection point. It cannot solve the secondary curve. So really it only solves one of the three parts of our geometry problem. Remember, we've got two curves, opposite directions, an inflection point at the glottis. So those are three geometry problems. Primary curve anterior, secondary curve posterior, inflection point between the two where we need to change directions. So now the predominant cause of intubation failure is no longer visualization, it's tracheal access, okay? So the DL systems fail because of visualization. The video laryngoscopes intubation systems fail because of tracheal access. And that tracheal access failure is because we have a partial evolution of tracheal access equipment. It can only be bent in an anterior fashion. The place we're failing now is the secondary curve, being able to turn posterior down the airway. There's a lot of training and a lot of tips and tricks to maneuver through there. Our tool eliminates the training and tips and tricks and means everybody can do it pretty easily. So now we're into the combined technique era, and that started in the late 2000s with fiber optic scopes being used as dynamic introducers. So now we move from the geometry model that's in the anesthesiologist's head of the three curve theory, or the three line theory, to the two curve theory. So that's a model change in the anesthesiologist's head. Now again, we're looking around the corner with the video laryngoscope. That gives us superior visualization. It's very easy to see the entrance of the trachea or the vocal cords. That gives us serpentine geometry with a dynamic introducer such as a fiber optic bronchoscope or a RSI dynamic introducer. We can solve the primary curve, and then when we hit that inflection point in that secondary curve, we can flex the tip posteriorly, solving both of those geometry problems and smoothly enter the trachea. And so this is the era of dynamic tracheal access. That's what we're selling, is a tool that can solve all three parts of the geometry problem. It can solve the anterior primary curve. It can move through the inflection point by articulating the tip posteriorly, and then it can travel down the secondary curve without any problems.